Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra class, Algebra II class, sorry. Today we are going to continue with matrices, and today in particular we're going to learn about matrix multiplication. There are two types of matrix multiplications. There's what's called scalar multiplication, and then just matrix multiplication. Let's first look at scalar multiplication, okay? Think about scalar. Think about the word scale. If you think about a scale drawing, kind of like on a map, okay? You'll have at the bottom a legend or a key, and usually, you know, if you measure the key, it's roughly usually about an inch. It's like 50 or 75 miles. Well, that's a scale. Every inch drawing on that map represents 75 miles. Okay, so that's where scale comes from. Scalar multiplication is kind of similar concept. Scalar multiplication is very easy, and all you have to do is distribute the value being multiplied to the matrix to each element within the matrix. So scalar multiplication will either increase the value of every single element in that matrix, or it will decrease it depending on what you're multiplying by. So for example, if you have matrix A here, scalar multiplication would be multiplying some value n to matrix A, and literally that value n has to be multiplied to every single element. It's that easy, okay? Scalar multiplication is really simple. For example, I have matrix A and matrix B. I want to find the value of 2A plus 3B. So I'm going to use scalar multiplication, and then I'm going to use the addition properties of matrices. So when I multiply 2 times matrix A and 3 times matrix B, this is what I'm going to get. 2A, please remember, every single element gets multiplied by this 2. So this becomes a 6, negative 2, 12, 8, 16, negative 10, 4, 10, 14, plus 3B. 3 gets distributed also to every single element. So I will have negative 6, 9, 6, negative 9, 12, 6, 12, negative 18, and 27. And now, just like you learned over the weekend, adding matrices is very easy. Element to element, okay? Element to element. So in this case, 6 minus 6, that's 0. Negative 1 plus 9, 8. 12 plus 6, 18. 8 minus 9, negative 1. 16 plus 12 is 28. Negative 10 plus 6 is negative 4. 4 plus 12 is 16. 10 minus 18 is negative 8. And 14 plus 27 is 41. Yes, sir. Let me see. This should be a negative 2. Thank you, son. So this should be a 7. Thank you. Good catch. Appreciate that. Okay. Pretty simple, right? Now, I can use scalar multiplication, guys, to solve equations as well. In this particular case, I want to solve 3x plus 4 times this matrix 2, negative 1, 3, 4 equals 17, matrix 17, 5, negative 3, and 1. Please, please be careful. Only the 4 here is being distributed to this first matrix. How would you know the difference? If it was in parentheses, then everything would be multiplied to every element in the matrix. But that's not the case. In this case, only the 4 is being multiplied. Okay? So, what am I going to have here? I'm going to have a bunch of different equations is what I'm going to have. I'm going to have 3x plus 8 equals 17. I'm going to have 3x minus 4 equals 5. I'm going to have 3x plus 12 equals negative 3. And I'm going to have 3x plus 16 equals 1. So all I did was multiply this 4 to each element, and then I set it equal to the appropriate element. Does that make sense? Now let's solve these. This is Mickey Mouse. So x can equal, when I subtract 8, well that's 9, so x could be 3, x is 3. And actually, would that work for everybody? Yeah, that would work for everybody. X is 3. So, in essence here, since this is the same x for all the equations, all you got to do is really just solve one. Yes, sir. Actually, yeah, you get 5. Yeah, the first two are 3. Let's see. And then this one we subtract it. That's negative. No, x equals negative 5 as well. And yeah, so x can equal 2 different values. Yeah, you do have to solve them all. X can equal 3 or negative 5, depending on which element you're working with. Sir? No, you have 2 different solutions. It could be 3 or it could be negative 5. Does that make sense? May I continue? Okay, let us continue. Oh, I just dropped my pen. Okay, now that we understand how scalar multiplication works, let's focus on matrix multiplication. In order to multiply matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. So please pay attention to that. The number of columns of the first matrix must equal the number of rows of the second matrix. The product will equal the first rows matrices times the second matrices columns. Okay? So, for my first matrix here, I have 3 rows. Okay? And I have 3 columns. My second matrix, I have 3 rows and 2 columns. So I have a 3 by 3 on the first, and I have a 3 by 2 on the second. The columns of the first must equal the rows of the second. The columns of the first must equal the rows of the second. Okay? If not, you cannot multiply it. Period. There's just no choice for you, unfortunately. Okay? So since you're multiplying a 3 by 3 times a 3 by 2, and the columns of the first matrix equal the rows of the second matrix, you are allowed to multiply the matrices. And the product will be a 3 by 2. So these guys allow you to know if you can multiply them. At the end, you're going to be left with a 3 by 2. Does that make sense? So you know what you're going to be left with, and you know if you're going to be allowed to do it by looking at the rows by columns. So how does this work? Okay. Looks complicated, but it's actually quite simple. Okay? First of all, this is a 2 by 2, and there's a 2 by 2. So the columns of the first equal the columns of the last, and your answer is going to be a 2 by 2 as well. So how do we multiply this? Please pay attention. First term times first term. You with me? Second term times third term down here. So basically, we're taking the first row and we're multiplying it to the first column. So this guy to this guy, and then this guy to this guy. Then we're taking the second row and multiplying it to the second column. Okay? Yeah, sorry. So we have now A11. Well, first we have to finish this top part. So we have A11 times B11. A12 times B21. Then A11 times B12. Then A12 times B22. Then we come down here. A21 times that first column. A22 times this second one. Then A21 times this guy. Then A21 times that guy. So, again, first element times here. Done. Plus second element times this guy. Done. Then this first guy again to this dude. Then this guy here to this dude. You with me? Okay, it takes time to get a hang of this. Then this guy times him. Then this guy. Then this guy times him. Then this guy times that. Then this guy times that. Yeah. This guy times that. Okay? No. They both multiply to everybody. Okay. This takes a little bit of time, so don't stress. This guy will be multiplied to here, then this guy multiplied to here. Okay, that's this. Plus, you still got to take these two guys and multiply them to here and to here. Okay, so yeah, first row goes to tops. First column goes to top row. Second column goes to bottom row, yes. And then you repeat the same thing from the second row. Here to there, here to there, here to there, here to there. Okay? Let's show you a real example so it can make a little bit more sense. Before you begin multiplying matrices, you must make sure, though, that the dimensions are correct, okay? You got to make sure that they can be multiplied. So before we actually multiply them, let's just practice that real quick. Determine if each pair of matrices given by the dimensions can be multiplied. Can a 2 by 3 be multiplied by a 2 by 3? No, because this guy and this guy are not equal, so no. How about B? 2 by 3 and a 3 by 4? Yes. The columns of the first are equal to the rows of the second. And my answer will be a 2 by 4. How do I know that? Because it's the leftovers. That will be my answer. How about a 1 by 2 and a 2 by 3? Yes, the columns of the first equal the row of the second. Yes. How about a 3 by 4 and times a 3 by 5? No. The columns of the first are not equal to the rows of the second, so no. So before you do any multiplication of matrices, whether it's a test or a quiz or an SAT homework, always make sure that you can multiply them. Always make sure that you're able to. Okay? Does that make sense, guys? All right. Let's do an example. Let's determine the product of each. Okay, first of all, this is a 2 row by 2 column. This is a 2 row by 2 column. 2 columns of the first are equal to the 2 rows of the second, so we're golden. Now, let's pay attention. 2 times 4, which is 8, plus negative 1 times 2, which is a negative 2. That's my first element at the top. Now, multiply 2 times 5, that's 10, plus negative 1 times 7, that's my second element. Is everyone with me here, my friends? Okay. Now, 1 times 4 plus 3 times 2. And last but not least, that's my third element. Now my fourth element, 1 times 5 plus 3 times 7. And my final answer is 6, 10, 3, 26. Does that make sense, guys? It's not that it's difficult. It's just remembering the right pattern. Pretty simple, no? Right? Everyone with me here, guys? All right, good. For B, this is a 2 by 2, and this is a 2 by 1. Will I be able to multiply this? Yes, columns of the first are equal to rows of the second. So, 1 times 4, that's 16, plus 4 times negative 5. I'm sorry. 1 times 4 is 4, Mr. Morrow, pay attention. 4 times negative 5 is negative 20. That's my first element. And remember, it's important to know that your answer is going to be a 2 by 1. So that means it's going to be 2 rows and just 1 column. So that's my first element of my first row. And then 2 times 4 is 8, plus negative 3 times negative 5 is 15. So my matrix solution is negative 16, 23. Is that making sense, guys? Yeah. Okay. How about for C? I got a 2 by 2 and a 1 by 2. No. The columns of the first are not equal to the rows of the second. No. Wrong. Cannot do it. Sir. Yeah. Not possible. Thank you, son. Yeah, you would literally put not possible. Nope. You can't switch it around. You can't do it like that. Okay? Now, wait a second. What if I reversed it, though? What if I reversed it, though? But that wasn't the question. If I gave you this, that's not possible. And you would just be able to say no. However, if I gave it to you in this format, this is a 1 by 2 and this is a 2 by 2. Would I be able to do it that way? Yes, I would. Okay? And in this case, the answer is going to be a 1 by 2. So it's going to be 1 row and 2 columns. So let's see how this would work, just out of curiosity. 5 times 1 is 5 plus negative 4. Okay? You with me there? and then yeah, and then I have 5 times 4, which is 20, plus negative 2 times negative 3, which is 6, and my answer would be 126, which works out because your answer would be a 1 by 2, 1 row, 2 columns. So this is actually a wonderful example. If I gave it to you the way I gave it to you in C, you cannot do it. If I presented it to you the way I followed underneath in blue, then yes, you could. Okay? But you cannot mix and match on your own. You got to follow the multiplication that they're telling you to follow. Make sense? Okay. And that's it. Why don't we do some practice now and make sure you got this. Thank you very much. Hope you learned a lot.